Okay, here is a question about electron group geometry. Alright, so again, electron group is going to be slightly different than the actual molecular geometry. We're just concerned about electron groups here. So electron groups would be anything that has a lone pair and anything that has a bond with it. Alright, so it's asking the question, what is the, talking about the shape of the bromate ion, and then what are the electron groups around the central bromine atom? So how many electron groups are there? And it even tells us here one electron group means one lone pair, one single bond, one double bond, or one triple bond. So that's one thing. The second thing here is what phrase best describes the arrangement of these electron groups around the central bromine atom. Alright, let's see if we can tackle this. We're dealing with electron groups here, and so I have this table that I just copied and pasted out of our notes. And so the ion again that we're looking to do is going to be this bromate ion BRO3 minus. And so let's come back here and let's just do the Lewis dot structure. We're going to have to do that first, and so let's do the bromate, and so we have BRO3 minus. Okay, let's do valence electrons first. So for the bromine there are 7 valence electrons. For the oxygen there are 6 times 3, which is 18 valence electrons, plus the 1 associated with the ion itself, and so that is going to give me a total of 26 valence electrons that I have to account for when I'm doing the Lewis dot structure of bromate. So I'm just going to put that Br there in the middle, and I'm going to have my 3 oxygens that are going to come out of here from the bromate. Okay, and so I have my molecules in place. Let's do valence electrons. So let's complete the octets around the bromates first. Okay. And then 1, 2, 3, 4, 5, 6. Okay, so here's bromate. And so let's count our valence electrons here. So we have 8 times 1, 2, 3. So I have 24 valence electrons. If you're wondering where I got the 8, there are 2, 4, 6, and the lone pairs. And the bond also has a pair, so there's 8, and I've got 3 of those around that bromine. So now I've got 2 valence electrons that I have to account for. So in order to complete that octet around the bromine, then I am going to put a lone pair right there. Okay, so I'm going to put that in brackets to indicate that it's an ion. It's got that minus charge. Now it's talking about electron groups here. And so how many electron groups are going to be around that central bromine? And so let's count them. I have 1, there's the single bond, 2, 3, 4, including that lone pair. So there are 4 electron groups around that bromate. So let's go back to our Alex. How many electron groups are? There are 4 around the bromate. And then what geometry best describes that? Well, if I have 4 electron groups around, that's going to end up being this tetrahedral. So each one of those bonds or those electron group designations coming off of that central A molecule can be either an atom or it can be a lone pair. And so this is going to be a tetrahedral shape. And again, with Alex, just remember, we're talking about electron groups in this case, not the molecular geometry. And so I have here tetrahedral that has 4 groups, and so if I click on check, then that should tell us that we are correct, and it does. And so again, we're dealing with electron groups, and in another video I'll go ahead and talk about the molecular geometry of each of those.